In this video, we're going to be looking at surds, what they are, and the common exam questions that you have to be able to do. So a surd is essentially a square root, okay? So it's just another name for a square root. No cube root, anything like that. It's just square roots. And what you would be expected to do, first of all, is to simplify them, okay? So to simplify a surd, such as root 50, that's how we kind of say it, square root of 50, we want to find factors of 50 that are square numbers, okay? Factors of 50 that are also square numbers. So you should know your square numbers from 1 squared up to 12 squared. So for 50, we could do 1 and 50. 1 never helps us, so we don't bother with 1. 2 and 25. 3 no, 4 no, 5 and 10. That's it, really. So these are the factors of 50 that we're interested in. Which one of these are square numbers? Well, only that one. If we discount the 1, then 25 is the only choice that we have. Okay. If we do have a choice, we always pick the largest one. So the largest square number is what we use for the next part. Okay. So we just have to rewrite 50 as the pair of factors, including the square number. And I like to write the square number first, just to make it easier. So 25 times 2. We've just rewritten 50 as 25 times 2, and we picked 25 because that's the biggest square number in this list. We can then split these two apart into two separate square roots. We just chop it down the middle. And then we chose 25 so that the square root of 25 would be 5. 5 times 5. Times root 2. Just like algebra, this times, we don't have to bother writing it. 5 root 2. Like that. Okay, so this is the process of simplifying. We're taking a larger number and we're removing the square factor and putting it in the front. Okay, let's try another one of those. Let's do square root of 18. So go to the side here. Don't bother with 1, 2 and 9, 3 and 6. That's it. The biggest square number here is 9. Okay, so we're going to write this as 9 times 2. Square number first. You don't need to do each and every one of these steps. This is me just showing you the sort of breakdown here. We could separate this into root 9 times root 2 and then just call that 3 root 2. Okay, so this is how we simplify our surds. I'll show you an example where we have multiple squares. Let's think root 48. 48 can be 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. And when we look at the square numbers here, we've got 4, which is 2 squared, and 16, which is 4 squared. So we want to choose the 16 and the 3, because if we choose a smaller one, we have to do the process a second time. We haven't fully simplified it. So we would have 16 times 3 here, which would be 4 root 3 when we do the kind of breakdown, as opposed to 4 times 12, 2 root 12. So root 4 is 2 times root 12, and then the 12 can be broken down into 4 and 3, so you'd have to do it a second time. So try to avoid that by choosing the largest square number factor. Okay. So now that we've got these surds here, like root 50 and root 18, next thing we have to be able to do is add them and subtract them from each other. So if we add root 50 plus root 18, that's not just root 68, okay? We can't add these together currently because they are different surds. They have to be the same surd if you want to add them. Again, it's like algebra, like 3x plus 4x we can do, but 3x plus 4y, we can't do much with that because they are different terms, and root 50 and root 18 are different. So when we simplified them, the 50 became 5 root 2, and the root 18 became 3 root 2. Well, now these are the same square root. The root 2 is the same. It's like 5x plus 3x. So we can make that 8 root 2's. You've got 5 of them, add another 3, you've got 8 root 2's. So adding and subtracting, we have to make sure it's actually the same root. And in the calculator papers, you'd be able to check this anyway. Your calculator will simplify for you. It will add these together, but you obviously need the working out to go with it. And the last part of Surds is this horrible thing, rationalizing the denominator. Okay, what does that mean? If we have something like 5 over the square root of 3, you're expected to know in the exam that you're not allowed to have a square root in the denominator of a fraction. It's just a thing. You're not allowed to have that square root there. Okay? And rationalizing it means turning it into a rational denominator. Root 3 is irrational. It goes on forever, like pi. We want to turn that into a rational number, like 3 or 2.5 or something like that. These are rational numbers. So how do we do that? As soon as you see a root on the bottom, times top and bottom by the denominator. Whatever that number is there, we times top and bottom by that. And what will happen is 5 times root 3, well, we just don't bother with the times, so we just pop them together like that. Root 3 times root 3 is kind of the reverse of what we did above. We can put these together under the same root sign, root 9, and that would just become 3. So the square root times the square root, that's a kind of definition, like the square root of 25 times the square root of 25, so 5 times 5 just gives you 25. So it gets rid of the root sign when you multiply it by itself. That's essentially what happens there. Okay, so if it's a single term, like root 3, root 11, whatever it is, times top and bottom by that. The second type, which is probably the hardest, is if you have root 3 plus 1. Okay, in this instance, we've got not just a single root like this, but it's got this added little plus 1, minus 2, whatever it is, like something that's been added or taken away from the square root sign. Okay, and in this case, we don't times by root 3 plus 1. We do the opposite. Whatever that sign is, we do the opposite. Okay, so if that was root 3 minus 2, it'd be root 3 plus 2. And the whole point of this is another instance where we see the difference of two squares. Because the top will be this. We don't have to do much with that. Just 5 times this whole thing. That becomes 5 brackets root 3 minus 1. And the denominator would be root 3 plus 1, root 3 minus 1. Okay. The whole point is that we're trying to get rid of the square root from the denominator, remember. So we're just going to go to the side here and look at what this expansion looks like. Root 3 times root 3 is just 3. Okay, root 9. Minus 1 root 3, which would look like that. We don't need to bother with the 1. Plus root 3. So that's plus 1 lots of root 3. And then 1 times minus 1 is minus 1. And the whole difference of two squares thing, one bracket being plus and one being minus, is that the two middle terms always disappear. When we apply that to the square roots, root 3 minus root 3 is 0. So this whole thing becomes 3 minus 1, 2, like that. So that whole denominator, that nasty thing there, all simplifies down to 2, and the numerator becomes this. Okay, so I know there was a lot there. We had to simplify the surds by finding the square factors, adding and subtracting the same surd, rationalizing the denominator when there's a single term, and when there's a plus 1 or a minus 1, we have to do the opposite here and do all this stuff to the side. So it is tricky, it's a high level topic, but when you see a square root on the bottom, you know that you have to rationalize it, and the question might not even tell you to do that or indicate any otherwise. So just when you see those, try to get rid of them, and that will nearly always get you the answer of a very difficult question. Okay, good luck.